Hi everyone, in this quick video I wanted to talk about change of scale, which the syllabus talks about as it relates to discrete random variables. Now I'm going to start with an example and the idea here, not using discrete random variables, just using numbers, so you can get a picture of what's going on here. So what do I mean by change of scale? So imagine if you have a set of numbers, here they are here, and let's say by change of scale we added 10 onto every number. So what we're doing to each number to get to the next number is we're adding on 10. Okay, added on 10 to get that one, added on 10 to get that one. Okay, so the question here would be, what happens to the mean and the standard deviation of these new set of numbers here as compared with the old set of numbers? Well, I think it's pretty obvious that if the mean, I'll use mu for the mean is 2 of this set of numbers, the mean of this new set of numbers is going to be 12. Okay, 10 more. So if we add on or subtract a number, then the mean, of course, is going to go up or down by that number. That's just obvious if you look at the diagram there, if we add 10 on. Now, what about the standard deviation? I'll use this sigma symbol. Let's say the standard deviation is 3 for this set here. Remember, the standard deviation is measuring how far spread out these numbers are. So what's happened to the standard deviation of this new set of numbers here? Well, if you look at it, they're not any further spread out than the original set of numbers, so the standard deviation stays the same. So that's the first thing. Adding on or subtracting a number certainly changes the mean, but it doesn't change the standard deviation. All right, now let's look at a change of scale if we multiply by a certain number. So here's my numbers here. Let's say they're 1, 2, and 3. 1, 2, 3. And let's say I multiply each of those numbers by 2. So our new set of numbers is going to be 2, 4, and 6. Well, the mean of the original set of numbers, I'll change colours here. The mean of the original set of numbers is 2. And let's say the standard deviation is 1. I don't know what it actually is, I'm just making this up. Let's say the standard deviation is 1, the measure of how far spread out they are. Okay, so for the new set of numbers that you see above there, clearly the mean has changed, and you can see the mean is going to be right here. 2, 3, 4, 5, 6. The mean is going to be 4. So we've multiplied the mean by 2. And you would find that if you multiplied every number by 3, you would multiply the old mean by 3 to get the new mean. Okay, what's interesting here is the standard deviation. Clearly, this set of red numbers here is more spread out than our original set of numbers. It's in fact twice as spread out. So the standard deviation here is actually 2. And that's an important result to understand. So the standard deviation is now doubled when I multiply by 2. So let's kind of sum this up in terms of discrete random variables. And I'm going to write some formulas down here. So if I have a random variable x and I multiply it by a number a and then I add on another number b, we need to know what the expected value of that random variable is going to be. And going on what I just said, we know that if we multiply by 2, for example, then we're going to have to multiply 2 to get the expected value. If we add on 3, that certainly makes a difference to the mean. So that would be the formula of this new random variable. If you multiply by 2 and add 3, then the mean of the new random variable would be multiply by 2 and add 3, or the old mean. A little bit trickier is if we think about the standard deviation. So I'm going to use this symbol here, the standard deviation of ax plus b. Now, adding b doesn't make any difference, as I've just said. So really, that is just a times the standard deviation of x. Now, remembering that the variance is just the standard deviation squared, the variance of ax plus b, remember the b, not going to make any difference at all, but the a is. In this case, because we could just go straight from here to here, we know if we square the standard deviation, we get the variance. So this is just a squared times the variance of x. So if you get a question where You might say we've got a random variable x, we give you the mean and the variance, and then we say we multiply by 2 or subtract 1, something like that. You could use these formulas here to work out what the new mean and new standard deviation is going to be.